In this example, we have a particle of mass 10 kilograms suspended by two strings attached to two fixed points. The 2 points are on the same horizontal level. So if we're to just draw what is going on, there's our surface, there is our particle. Two strings are attached to the particle. We know that the particle has a mass of 10 kilograms. That means the weight, 10g, will be a force operating downwards. We're told that they make an angle of 40 degrees and 60 degrees respectively. So there's 40 degrees. There is 60 degrees. Each string will have a tension. Their tensions are not necessarily the same. So I have T1 going up and T2 going up. Now in this instance, what we have is our unit vectors I and J. I goes horizontally and J goes vertically. What we've drawn so far is a force diagram. Now the weight is certainly on the vertical axis, but our two strings are not. So to solve this problem, what we need to do is resolve those forces. So let's see what we have. We know we have a triangle which has an angle of 60 degrees, 40 degrees. So the angle between T1 and T2 is 80 degrees. I'm going to resolve T1. If I consider that, what I have is a right angle triangle. And what I want to do is find the horizontal and vertical distances on that triangle that form the right angle. I know where the angle of 40 degrees is because the surface at the top and the bottom side of my triangle are parallel. I know 40 degrees in the bottom corner. So if I was going to work out the length of the adjacent side, know the hypotenuse is T1. What I can do is I can use my right angled triangle formulas. So what I now know is the magnitude of T1, cosine 40 degrees, going to be my horizontal length. I know my vertical length will be my opposite side. Opposite side involves sine. That's going to be T1 sine 40 degrees. Okay, now I'm going to look over at T2. T2, I have another right angle triangle. I know the 60 degrees, so I know the 60 degrees. Again, if I go to work out the horizontal length, it's the adjacent side, that will be T2 cos 60 degrees. The opposite side on that triangle, therefore, will be T2 sine 60 degrees. The other thing I need to know is the weight. The weight, obviously, I have going down as 10g. So, if I want to work out the resultant force, what I'm going to do is add the horizontal components together and the vertical components together, but I must be careful because there is direction. So, if I consider horizontally from the particle going in the positive direction, I have T1 cos 40. In the negative direction, I have T2 cos 60. So I'm going to have T1 cos 40 minus T2 cos 60 in the horizontal direction, which is unit vector I. Now we're going to consider vertically. Vertically going up, I have T1 sine 40 plus T2 sine 60. But going down, I have 10g, so I must subtract it. And that is in the j direction. Now, because we're in equilibrium, that means all the forces sum to 0. So the resultant vector will equal the 0 vector. That means that T1 cos 40 degrees minus T2 cos 60 degrees, the I component will equal the 0 vector, 0i plus 0j, so that will equal 0. Similarly, with T1 sine 40 degrees, T2 sine 60 degrees minus 10g in the j direction, that will also equal 0. I now have two equations that I can solve simultaneously. When I do so, that gives me T1 equals 49.76 newtons, T2 equals 76.23 newtons. Normally for newtons, we would write the capital letter N.